Welcome to the Tech Ed Podcast, where we visit with leaders who are shaping, innovating, and disrupting technical education. People who are not afraid to think differently, not afraid to try something new, all with the goal of securing the American dream for the next generation of STEM and workforce talent. It's Matt Kirkner with the Tech Ed Podcast. We spent an entire day on the floor of CareerTech VISION. It's the annual conference for the Association for Career and Technical Education, and we went in search of the most innovative and advanced technologies coming to classrooms in technical education all over the United States of America. Hundreds of exhibitors, so many innovations, but these stood above the rest.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I'm spending time today with Katie George. Katie is the Director of Partnerships and Ecosystems for Transfer. Katie, so awesome to have you on with us. And just tell us a little bit about Transfer.
Absolutely. So Transfer is primarily known as a virtual reality company, but we're actually so much more than that. And we do a lot for workforce development and trying to connect individuals that maybe not have a direct path or training to a career. What we do is try to help set them up for that. So we do that in two different ways, really. The first one is career exploration. So we'll have individuals from young ages, maybe with groups like Boys and Girls Clubs or middle schools, things like that. They'll put on a headset and they get to experience what it's like to do a task in that career. But then once they get on that pathway, what we do is really try to connect them to the training programs that have that. And then we develop out full-on training programs that give them a chance to really do those hands-on tasks without being quite hands-on. So it really boosts their confidence and comfortability and doing those things when they get to that on site.
So it sounds like it really is all about that complete pathway from career exploration and inspiring young people toward careers they might not even know exist, and then giving them some of those skills and competencies that are necessary to be successful when they get there. You started by mentioning that you're known for virtual reality, but you do so much more. Certainly when we think about VR, we think about cutting-edge technology. Tell us about some of the technology that you have on offer here at ACTE.
Yeah, absolutely. So here we're showcasing our VR technology, and both in our career exploration and in our training components. So even the teachers here, what they're doing is they're putting on the headset to see how well that a student can actually experience and be very immersed in those areas. And the other thing with that is, in some cases, schools may not necessarily have the funding to create some of these training pathways in various industries, but they'll have the opportunities for the students to get experience and training from it just by doing it in VR. So it opens up the network of what a school can offer to really get those kids that very broad understanding of the careers that are available to them.
So when we think about budgeting and career technical education, sometimes teachers or CTE directors might even feel like they have to pick. They may have a bunch of different options and they have to choose based upon limited funding. And here you're giving them the opportunity to open up a wide variety of different career pathways, different opportunities for students to learn about. Tell us a little more about the experience of the student as they're actually experiencing the technology.
Yeah, absolutely. So one of the great things, especially when it comes to career exploration, a student can put on the headset, and what they can do is experience what it's like to be like even a lineman training. They can practice being a surgical tech. So they can practice doing a knee surgery or knee replacement. But they can even do, automotive technology. They can do construction. They can do welding. I mean, we even go as far as having aviation maintenance, what a lot of schools don't have, but it allows them to experience that. So the students really get to be in there and have a very immersive ability to learn how to do those tasks. But if it's actually in a training component, what we do with that is we work directly with the industries that are hiring these students to develop out those simulations that they would be working on. And then they actually get a mastery score as they're rating it and working through it so that individuals can see really where their deficiencies are or where they're really great at and get an understanding of what they like and where they want to go in their future.
And then use that information to fine-tune skills. If maybe they're excelling in a certain area and they need a little bit extra time in another area, you've got the technology embedded right there to let them know that. Maybe they need to go back and do a little bit more training or experience the product or the solution just a little bit more as they continue to hone those skills and really prepare themselves for incredible careers. And you mentioned a couple of them. I mean, aviation maintenance, is that what you said? In healthcare, advanced manufacturing. Give us a little bit more on the types of careers that you're preparing students for.
Yeah, so what we'll do is we'll actually dig into that industry and work with the companies and say, what are the up-and-coming careers that you desperately need to hire for? And then what we'll do is we'll work on building those training pathways and then introduce them back into the school. So like with aviation, we do a lot of the grounds work. So, when you're on a plane and you see them, doing the signs and everything to pull the plane in. We actually have training to do that because it was a great need. Now we're even looking at, because of all of the changes within the flight stuff in aviation, is do we end up doing flight attendant training, things like that. When it comes to healthcare, what we're doing is patient care. So it could be something like a CNA training, but then also a surgical tech, but also an EMT. So we're looking at all of the various ways to connect to see where the need is, where the demand is.
So you think about all of these different career pathways, being able to experience them on one platform can certainly understand why this training platform and why this solution is becoming so ubiquitous. But tell us now, if I'm a technical education teacher, if I'm a nursing teacher, if I'm an instructor in an electromechanical engineering program, why would I want to bring this technology into my classroom? What is your value prop when you're talking to those folks?
So there's a couple ways that we can actually do that. In some cases, it's within the younger groups. We can put them in the headset so that they can truly immerse themselves and get comfortable with being able to do those tasks so that they feel confident when they actually get to the higher programs and actually are on task doing the jobs real hand. The other thing with that is a lot of the supplies and materials and stuff have a lot of high cost to them. When they incorporate VR, it actually allows them to be able to do tasks that maybe the schools can't necessarily afford because of the materials. So there's a lot of different capacities that we can look at of where it shows the value to incorporate it into a training program.
Making students feel comfortable, giving them the competencies they need, and at a price point that makes sense for education. Katie George, the Director of Partnerships and Ecosystems for Transfer, thank you so much for spending some time with us.
Absolutely. I appreciate the time and look forward to what we can continue doing, working together to change the landscape of technology and education.
I am joined by Mr. Paul Perkins. Paul is the president of Amatrol, a behemoth in the world of technical education. And Paul, it's so great to have you with us. Take a moment to just share with our audience, what is Amatrol all about? What is your mission and what are you trying to do?
Well, thank you, Matt. It's a pleasure to be with you today. And Amatrol is a developer of learning systems for technical education, and the areas that we specialize in are Industry 4.0, working with advanced manufacturing and logistics, and also working in the energy field as well. And we develop interactive multimedia learning software programs for teaching concepts, and we develop hands-on training workstations that allow people to develop technical skills that can get them real jobs.
And none of that happens without tremendous amounts of innovation. I know innovation is absolutely at the core of so much of what you do. And in as much as you're constantly coming up with new products, new innovations, new curriculum, new e-learning, what's at least one of the cutting-edge things that you're working on and that we're talking about today?
Well, one of the latest things that we're working on is a product that we call the 895 Smart Controls Troubleshooting Learning System. And what it's designed to do is to teach advanced programmable controllers and networking and the types of skills that are associated with the latest products that are coming out from the leading companies in the automation field.
Nothing happens in a manufacturing floor or manufacturing operation without a programmable logic controller, that computer that's taking inputs and outputs and monitoring all that information and telling systems what to do, really the brains in so many ways of advanced manufacturing. So tell us, if I'm a student and I'm working on a trainer like this, what are the types of experiences that I'm going to have?
What's unique about this product is that it's not just one programmable controller, it's multiple controllers, different models and potentially different brands, but more importantly, it's a variety of controllers that all can be programmed and learned individually, but also students get to learn how to make them interact with each other. And that's what's happening in the field of Industry 4.0 today, is we're looking to try and connect the various intelligent devices on the plant floor, and those skills around how to develop the communications and how to get the data, and of course how to analyze the data, are the skills that are most in demand today, and that's what this product teaches people.
And it is really so fascinating to look at how technology is changing, how technology is changing the world of manufacturing, particularly. Everything is connected. We're pulling data, we're sending it up to the cloud, we're gathering all this information. That, again, is the future of advanced manufacturing. So specifically, if a student is working on a trainer like this and they're going through a series of exercises, give us an example of some of the things that they might be doing.
Well, one of the most important things they're going to learn is how to troubleshoot the system. And what we have done with this product is to have incorporated a unique computer-based fault insertion system that we created a number of years ago called Fault Pro, and this system will put faults into the network, into the PLCs and the other devices on the training system to allow the students to actually see what happens when things don't work. And then their goal is to learn the most efficient, effective way to work through a troubleshooting sequence so they can solve the problem and get the system back up and running in the shortest time. And that's, of course, downtime is the thing that every manufacturer is looking to minimize, and that's a key part of the skill set that's being developed in this training device.
I think you make some really good points, because the truth is that troubleshooting is a learned skill. It is something that these students don't come to this naturally. They have to understand how to take an entire system that may not be working, figure out why it's not working, cut the problem in half, cut it in half again, and narrow down on what is that specific root cause. We do so much of that in manufacturing, and the quicker they can do that, the quicker that line is going to come up and running, the quicker we're going to be meeting customer demand, making money in manufacturing, which is at least one aspect of that's really, really important to manufacturers. So very important, Paul, for students to learn those valuable troubleshooting skills and all of the other skills on a trainer like this one. So now they take those skills and they go out into the workforce and they find jobs. And I've got to believe that something like the 895 prepares students for all kinds of careers. Give us some examples of the kinds of careers this would prepare students for.
Well, every company that has automation needs people to maintain, install, troubleshoot, program the system, and those jobs are in high demand right now because there just aren't enough people that know how to do those types of skills. And so the job titles that people could typically have, it might be an industrial maintenance technician, it could be an automation technician, could be automation engineer. This product is well designed to be able to prepare a variety of people that are going to be somehow involved in the maintenance or the optimization of the systems.
Industrial maintenance, automation technician, automation engineer. It's fascinating to think about the amazing career opportunities available to students who are choosing those types of endeavors as they go through their education pathway, be it high school, community college, technical college, university, whatever it is that they choose, finding ways and paths to amazing careers when they get there. I know that's a huge part of why you develop a trainer like this, is that we want students experiencing this technology in the classroom. What advice, Paul, would you have to an instructor, to a teacher who's delivering this kind of learning on why they should have something like this in their training lab?
Well, the most important reason to have something like this is that it is working with the latest technology from suppliers like Rockwell Automation, and the training materials that are available out there today just don't cover some of these latest technologies, and we've actually partnered with Rockwell in developing this product, and having access to that information has allowed us to incorporate the training into the training materials, these latest technologies. And so an instructor, rather than having to take a year or 2 years to develop their own curriculum, and by then the technology has leaped forward to another version that they would have to redevelop again, they can have this product and instantly have the latest teaching capability in these technologies.
And the technology really is moving that fast and leaping ahead into where something a student is learning today in a year or two could be totally different. And so a teacher or an instructor that's developing their own training program, as opposed to leveraging existing curriculum from a company that's innovating as quickly as Amatrol, those are the instructors that are going to continue to bring cutting-edge learning systems into the classroom. So very important as we look to the future of advanced manufacturing. So I want to thank my dear friend Paul Perkins, president of Amatrol, for joining us here on the Tech Ed Podcast, talking about cutting-edge learning systems in the world of controls. And Paul, thanks so much for being with us and for all the innovation taking place in Amatrol.
Well, thank you, Matt.
I am joined by Peter Webb. Peter is the co-founder and the CEO of Mars Farm. You are going to love this technology. Peter, welcome to the Tech Ed Podcast.
Thanks, Matt. We're psyched to be here in Phoenix. So we manufacture, design, and sell all these greenhouses ourselves. We're based in St. Louis, Missouri, and the whole vision of the business is that we want to provide each student their own greenhouse. That way, they can make decisions about what they want to do and what they want to grow inside of it.
So every single student has their own greenhouse. We've seen training programs where students are all in the same greenhouse. Really great learning opportunities there. But here, every single student has their own little greenhouse. Tell us a little bit more about the technology. How are you going about doing this?
Yeah, so the box is about 1.5 feet tall by 1 foot deep and about 1.5 feet wide. So it's pretty small, but we put LEDs in it, so that means the power is pretty minimal. The whole thing only uses about 50 watts, which is about a regular light bulb. So that lets you get 20 of them on one outlet. And again, that's our vision for teachers, is to be able to have 2 boxes side by side, and one of them be 90 degrees, one of them 70 degrees, grow the same plant, see what happens.
So it's really about experimentation. It's about changing variables and understanding what those changing variables do to the outcomes, which is a great way for students to learn, right?
You nailed it, Matt. That's exactly what we're about. You know, a student, when they see a plant side by side with another plant and one of them's wilting and one of them's looking great, it's pretty obvious what's happening. And more importantly, if there's 6 plants in the box and one of them's doing great and it's a different type of radish from all the rest, they're learning that maybe some types of plants, some cultivars, are better than others. And that's plant science.
And as plant science for sure, and as we're sitting here in this world of whether it's Industry 4.0 or whether it's the the AI revolution and machine learning and so on, I can't help but think about the fact that in a way you're almost taking students and giving them an experience about changing variables, understanding outcomes, and then gathering data. Is that what they're up to?
Precisely, and we as a business are excited too to be able to see behind the scenes. Frankly, we get to see what's happening in over 100 boxes all over the United States. We're right now actually in 600 schools, and about 150 actually of those have live data monitoring. So they're sending CO2 data, temperature data, humidity, all of that, as well as images every hour to our database, so we can share that with them and tell them how their plants are doing as well. And guess what? We're using ChatGPT on our side to figure out how to do that.
So I mean, you think about it, you look at the experience and you think about a student, going through, having their own greenhouse, changing variables, growing plants and so on. But really then you add on top of that, you're creating your company this huge, huge data set of all of these individual experiences as the variables are changing, what's happening. There has to almost be other applications, certainly the education application, but what else do you do with that data?
Yeah, so one example is a program called Growing Beyond Earth. So NASA is funding a botanical garden in Miami, Florida, called Fairchild Tropical Botanic Garden. They buy about 100 units every year from us and then distribute those to schools. NASA takes one of our boxes, puts a $500,000 sensor in it, and then they change the lights so they're the exact same as what's on the International Space Station.
Wow.
That then lets them send out 6 types of radishes to every school across the United States, and now NASA gets a data set of 3,000 radishes with the same lights as what's going to be used on the space station. And that's how they pick. Actually, the last two plants that were grown on the space station is due to that program.
Unbelievable. So it's got to be just hugely rewarding for you to know that the technology, the innovation that's happening at Mars Farm is actually being used by an organization like NASA to learn more about eventually feeding the world and growing plants in other environments, maybe even in space sometime. Is that the Mars Farm idea?
We've realized that if we want to get students excited about agriculture and growing plants, which frankly they're pretty slow, we like to joke that we have the world's slowest robot.
Okay.
But what it helps you do, when you take photos every hour, you can make a time lapse. Now you can go back in time and you can look at those plants and say, hey, they started to wilt on this day. And you can then realize, oh, the water ran out on that day. So you can deduce information from that. So, forgetting me aside, while we're learning, it's about the students. And they care a lot more about the outcome if they know NASA is going to be looking at the data on the other side.
Absolutely. And imagine as we think about students going on to whatever comes next in their career, sitting around the dinner table with mom and dad at night and saying, hey, I worked on a project today that NASA is actually using to innovate. So tell us a little bit about the student experience as they're using the system. What is it exactly that they're doing day in and day out?
Yeah, so your average cycle of growth in one of our products, it's about 28 days. So we try to fit it conveniently into a semester. So a teacher can have about a 6-week lesson plan where they set up the box, they build it. It's acrylic panels that have a reflective wall. So all the light that's produced inside, it gets reflected around so that 3 times as much light makes it to the plants as if we didn't have these walls. Wow. So that's really a way that we're maximizing the efficiency, and the students then they learn about this. They learn about the equipment in the first 2 weeks, and then they plant the seeds. So they mix up the seed or the fertilizer with the media, plant the seeds, and then check on the plants every week, measure them, put all that data in a spreadsheet, and then that's what goes to NASA.
Awesome. And is it about a semester experience typically?
Yeah.
And in what courses too? Tell us about the coursework a little bit. Where is this embedded?
career and technical education.
Right.
It's where we are. These teachers, they understand the value of equipment as a means to keep students up to date and prepare them with the skills they'll need to actually be successful. And frankly, the way that the United States has produced large amounts of food for the rest of the world for the last 100 years is great thanks due to our high school career and technical education programs. If you don't go to college as a farmer, we have the high school agriculture teachers to thank for training all these great farmers that grow our food.
And they really are doing great work at high schools all around the country. Certainly, farming would be one career opportunity, but It's one of many, right? So tell us a little bit about the types of careers that students might go on to eventually after these types of experiences.
Yeah. So, starting with farming, Future Farmers America is the largest student organization in the United States. So when you look at what could those students do from a rural area, the answer is very different from an urban area.
Sure.
So we're based in St. Louis. That's where a company now known as Bayer, formerly Monsanto, is based. They employ thousands of people, scientists, data scientists, engineers, technicians, agronomists, but agronomists that analyze data sets. These are highly technical STEM careers. And so we see ag as not just, ag at the point where you're growing the plants, but ag as the entire supply chain. Ag as, the technical infrastructure that runs our grocery stores, that makes sure the tomatoes get to your shelf in time.
It really is easy to forget about all the incredible career opportunities that can exist for students as they're learning about agriculture, and you did a wonderful job there, Peter, of explaining to our audience exactly the types of opportunities that are available to these students. One last question for you as we wrap up our time here with you at ACTE, and that is, as we think about the future of technical education, we think about teachers and CTE directors and so on bringing technologies like these into the classroom. What is your message to a teacher when you're sitting down and saying you should be using Mars Farm in the classroom?
You hit on it a little bit earlier with, I feel like everybody's talking about artificial intelligence these days. And I like to joke that the one job it's not coming for is plumbers. Nobody at OpenAI wants to get rid of the plumbers.
Right.
And it's because it's very complex to work with your hands, right? And that's something that's not changing. So career and technical education, it understands that not everybody wants to sit at a desk, right? It understands that there are a lot of careers that require both intelligence and physical ability. You have to be able to manipulate things with your hands. You have to be able to understand by looking at a plant why it's starting to die. So those kinds of skills we're not going to have AIs that are great at for quite some time. So we're trying to make sure that teachers know that information so they can stay equipped with what careers they should be preparing their students for.
Awesome. Yeah, you're a great innovator. You're a great leader. You've got great technology. You're a great advocate for career technical education as well. Peter Webb, the co-founder and CEO of Mars Farm. Thanks so much for joining us on the Tech Ed Podcast.
Thanks so much, Matt. I'm delighted to be here.
It's my opportunity and my pleasure to introduce to the Tech Ed Podcast my dear friend Chris Rowe. Chris is the managing director of LJ Create, all the way from England, doing some really, really cool stuff around EV technology, which is the topic of our conversation today. And I'm, first of all, going to ask you, Chris, to tell our audience a little bit about LJ Create. What is your mission? What do you do? And tell us about the company.
Thank you very much. So LJ Create is an English company, offices here in the US. We sell to 40, 50 countries around the world, and we produce equipment for engineering, motor vehicle repair, and STEM education, selling to schools, universities, and colleges all around the world.
And we're here at ACTE learning about all kinds of things, but one of the things that our audience is really excited to hear about is all the phenomenal new technology taking place in career technical education. I understand you have some cutting-edge technology to talk about. Tell us about what the newest and latest and greatest products from LJ Create.
Okay, so for us, the last year has been all about electric vehicle technology. We see absolute need to teach people how to repair electric vehicles, how electric vehicles operate, etc.
And you've got some cutting-edge technology right here in your booth that does exactly that. Tell our audience a little bit about what you're introducing here at ACTE.
Yeah, a range of panels. As I mentioned, these are intended to show folks how to stay safe around electric vehicles, how the electric vehicle operates, and then most importantly, how to fix them when they go wrong. And so we create these products just like this panel here, and we lay out the whole of an electric vehicle system in a way that's safe for students to use and explains the whole system to them.
So learning about the technology, learning about how to use the technology safely, how does it operate? Give us a little bit more about some of the competencies specifically that students would be learning using this training system.
Okay, so let's take a look at staying safe, for example. Obviously, with an electric vehicle, you've got somewhere around 400 volts in the battery. That's 400 volts fed around the electric vehicle, and so unlike a regular vehicle breaks down on the side of the road, somebody comes along to help you, opens up the hood, there's 400 volts under there. So it's obviously possible to do yourself great damage with a electric vehicle. So step number one, how to stay safe. What are the things that are built into an electric vehicle? The service disconnects, the first responder loop, the service disconnect plugs, and how do these operate, and how do they shut the vehicle down to shut off that dangerous voltage and make it appropriate to work on.
So just on the topic of safety, thinking about all the different things that students can learn on a trainer like this, and understanding how an electric vehicle operates, and understanding about the careers in the electric vehicle industry, and what kind of careers does this type of training lead to?
Okay, so your most obvious is automotive vehicle workshops. These are guys who've been repairing regular motor vehicles, and now, in addition to your petrol engine or your diesel engine vehicle that pulls in, now you're going to start to see electric vehicles that don't work, and we have to fix those somehow. But it's not just those careers. We've got careers in the installation, for example, of charge points. So over the course of the next decade, the USA is going to need literally millions of charging points installed, and right now the folks who are going to install those charging points don't have those skills. So another opportunity. Manufacturers, so we're manufacturing batteries, we're manufacturing traction motors and all of the equipment that goes into electric vehicles. So those manufacturers need staff trained and upskilled also.
It really is an exciting future, isn't it, for our young people and people of all ages as we look at advancements in transportation technology, whether they're looking for a career installing the charging systems, whether they're working in a manufacturing operation that's using the latest and greatest in manufacturing mechatronics technology to manufacture these vehicles. This is exactly the competencies that those students and those young people are going to need. I would love to hear, and as much as we're here at the ACTE show and so many great instructors, technical educators are with us at this particular show, Chris, tell us a little bit about why those who are professionals in the field of career technical education should be thinking about using these types of systems in their classrooms and their labs.
Well, the first thing is, of course, they're safe. In this particular issue, just like those first responders that are pulling up next to the car broken down on the freeway, do you really want 17-year-old students poking around inside the hood with 400 volts sitting there? So that's the first thing. And it's also laying out a system and imparting skills in a organized fashion that's away from the vehicle. So you take a look at a vehicle is constructed for many reasons. Moving people around is the most obvious. It's not constructed to allow students to see exactly what's going on inside it. And that's what we're doing. We're taking what's going on inside that vehicle and we're laying it out in an organized fashion for students.
It's really interesting and fascinating, and I think exciting to think about what the future of these labs are going to look like. You make some great points when we're learning about electric vehicles, putting our head underneath the hood of something, not particularly working with it safely. Obviously, that could lead to disaster. We don't want students doing that. We want them around safe trainers where you can put a number of different students around the trainer at the same time, learning from each other. The instructor can use it as a demonstration tool, or we can have students doing the skills and learning the competencies on the trainer right in the classroom. This is the future of career technical education. Chris Rowe, Managing Director of LJ Create, joined us to tell us a little bit about the cutting-edge technology in their portfolio. Thanks for being with us, Chris.
Thank you.
It is my great pleasure to introduce a dear friend and somebody who is no stranger to the Tech Ed Podcast, Paul Aiello, Executive Director of Education for FANUC America. Paul, tell us a little bit for our audience, what is it that you're about, what is your mission, and what are you doing here at ACTE?
Good afternoon, everyone. What we do at FANUC, we have one mission. We are really about solving our customers, manufacturers' challenges. And that can be everything that they need to automate, from production to throughput to packaging to welding, you name it. But the number one concern of our customers and the manufacturers out there is their workforce. How do we find talented people? That's my role within FANUC, is to help bridge that gap between industry and education to make sure that schools are teaching students on real technology so they're prepared to enter the workforce and building that pipeline for industry.
And not just real technology, but cutting edge technology in so many cases. And I know you've got some great cutting edge technology on offer here at ACTE. Paul, tell our audience a little bit about what you're featuring.
Yeah, so a lot of what we're featuring is our collaborative line of robots. So interactive, human-safe robots that you can work alongside. But in this particular case, one of the most advanced technologies that we have is a machine tending robot for loading and unloading a machine. And you could say, that's happened for years. We've been doing that. But now the ability to use a collaborative robot with an Ethernet cable with a product called Robot On Site allows us to quickly and seamlessly connect the robot to a CNC so that you can do a quick integration of doing that setup and load and unload process.
So if I'm understanding this right, you've actually got a collaborative robot right here. It's loading and unloading a machining center. So tell us a little bit about the machining center behind the robot.
So the machining center itself is a 3-axis mill. This is a LaVille machine, and it's machining these parts. And what's happening is the robot then is going to go in, actually open the door by itself, load and unload those parts into that machine.
So you've got an industry-leading robot, you have an industry-leading CNC control, you have an industry-leading machine tool, all of this combined into one opportunity for learning. Tell us about the competencies and the skills that students are gaining as they're going through the exercises.
What's really interesting about bringing real industrial products into the classroom is, we're raising the bar for students. Instead of lowering the bar so that everybody passes, we're challenging students to understand about technology that was once thought to be only taught in a post-secondary or a very skilled technical training center. So now students, we've kind of demystified the requirements and the skill level to operate this technology. So that's what we're focusing on. But more than that, what we've done is we've shared that industry curriculum directly with schools. So they're learning the exact same way that we teach our industry customers. That's the key advantage, that it's not an academic equivalent or an academic purported program that aligns to industry. It is the real industry training that's available.
So students are learning exactly the same competencies that somebody in an industrial training program would be learning, getting themselves set up for really, really cool careers in advanced manufacturing. What are some of the careers that this type of learning could lead to?
Yeah, it's incredible. So right out of the gate, if a student is taking this, whether it's at a high school or community college or university, whether it's part of the military transition assistance program, returning citizens that are maybe just as involved individuals, can learn the skills to get them into the door. It opens the door to a career and a job in manufacturing. So operators, technicians, programmers, goes on from there where you can become service people, installation engineers. There is just a myriad of options. And it doesn't just stop with the electrical or the mechanical side. We teach offline programming, really the digital twin to this technology, through RoboGuide, through our simulation software for the CNC, that allows students, if they're really graphically oriented, where they want to follow that path and sit in front of a computer, they can work through all those challenges.
So it sounds like whether I'm somebody who's going direct to workforce, where I'm going to leave my high school and maybe program or operate industrial robots, or I'm somebody that might be going on to a technical or community college, I might be learning this in my technical or community college, even students, and especially students on the way to an engineering program, all of these types of competencies are available, leading to just this huge wide variety of careers. Really, really exciting for students, exciting for technical education instructors and teachers as well. So what's your advice to a teacher, to an instructor, to a curriculum director who's thinking about how to teach advanced manufacturing? Why would they bring something like this into their classroom?
So I would say this to any teacher, any school, really, any administrator, is talk to your local industry. Get engaged with who are the employers. So those students are going out to seek employment with all of those companies. What technology are they using? Whatever technology they're using, make sure that you're implementing that within the classroom. And we get very direct with schools a lot of times where we tell the schools, you know, the customer of a school is the employer. The goal of the school is to build that talent, to build that product that makes them hireable for all those employers. That's the method of success. So alignment is key. So part of that is when we talk to school is use the real technology, put it in the classroom. You have companies like Fanuc and others that are now more than ever open and willing to share that with schools so that there is that direct connection.
The employer in a given region, a given district, that is the customer of career technical education. Let's make sure that we are aligning skills, competencies, curriculum, experiences with the expectations of those employers. That's how we create really, really cool careers for young people and really people of all ages. Paul Aiello, Executive Director of Education for Fanuc America. Wonderful conversation about cutting edge technology. Thanks so much for being on the Tech Ed Podcast.
Thank you, Matt.
I am joined right now by the National Sales Manager U.S. for a company called Creaform. His name is Jared Schmidt. Jared, welcome to the Tech Ed Podcast. And if we were having a conversation over dinner and I said to you, what is Creaform? What do you do at Creaform? What would you tell me?
Well, I tell you, Creaform makes technology for 3D measurement. So we have scanners and the software to support that mission.
Awesome. So you've got scanners, software to support 3D scanning. What is 3D scanning exactly?
So 3D scanning is a way to take dimensional measurements on an object. So we basically point the scanner at the object. It projects a light pattern of some kind, and we read that light pattern, and we reproduce a digital copy in our software. And then from there, you can redesign from it, or you can build something maybe designed to attach to it. You can do analysis for like corrosion, or you can do just full quality control.
So in my days of design engineering years and years ago, and thinking about having to sit there with a dial caliper or a micrometer or even a tape measure or ruler, taking measurements, understanding points in space, and then coming up with a drawing or a schematic or of some sort of that particular part, what you're telling me is we can take a hand scanner or a scanner of some sort, literally use pixels of light, scan that particular part or that unit, and you can get the dimensional measurements of that part. That's absolutely fascinating that you can do that. So we're here at the Career Technical Education Show. Are you taking this technology into the classroom? Tell us what students are doing with the technology.
Well, absolutely. I mean, students are doing everything industry is doing, right? So, I mean, they're scanning their coffee cup or a piece of fruit to make something for AR, VR applications. They're designing brackets and connectors, and they're designing whatever it is. We have universities using it in their race teams to design components there. So they're doing everything industry is doing. They're doing analysis for quality control as well.
So they're learning engineering, they're learning reverse engineering. Are there other competencies that they're learning when they're going through this process?
Well, sure. I think they're really understanding dimensional measurement. So where are the errors in measurement? Because if you think about using some of those hand tools, you're getting a measurement that's just out of context. It's just a measurement. You also can have a lot more error in measurement with hand tools. And I think they have an opportunity to see that when you're using digital tools like our handy scanner or our peel scanner, that you get a reliable, repeatable data, so they get a better understanding of where errors in measurement can come from, and they get a better understanding of accuracies and tolerances.
And what engineering program, what metrology program, what quality program, what high school STEM program wouldn't want to bring those competencies into the classroom? That makes all the sense in the world. Give us an idea of some of the careers that students may pursue after being inspired by this technology.
One of the biggest demands that we have is actually being a field technician for scanning pipeline for corrosion. They are very short-handed. We also have a lot of customers telling us they can't find people to operate their quality control instruments, whether it be a scanner like ours or hand tools. So these are really great career paths. They pay very well. So, but then of course we have our quality control for automotive or design. Clay model design. So there's just, it's endless. AR, VR applications. All the studios are using our scanners to capture data to create digital replicas. So yeah, it's almost as limitless as the tool.
Some of the things we love here on the Tech Ed podcast is just products and platforms that can inspire students around a wide variety of careers. And I think you did just a great job of explaining whether I want to be a pipeline technician, I want to work in quality, I want to work in engineering, I want to work in measurement and dimensional accuracy, all these great career pathways that exist as a result of learning on the Creaform technology. So let's pretend for the moment that I'm a high school STEM teacher, or I'm a technical college instructor, or I'm a university professor. Why would I want to bring this technology into the classroom?
Well, I think you want to expose your students to what industry is using. If they're only learning how to measure with a calipers or learning how to measure with a tape measure or height gauge or something, they're sure that's useful. But more and more customers of our commercial customers are getting away from hand tools because of the potential error of user using it and the repeatability problems. You get really repeatable, reliable data from our scanners. They're world-class hardware products supported by world-class software.
Yeah, world-class hardware, world-class software, world-class people like Jared Schmidt, the National Sales Manager here in the United States for Creaform. And Jared, thank you so much for spending some time with us on the Tech Ed podcast.
Thanks for having me. It was great.
It's my opportunity to introduce to you my good friend, Terry Graham. Terry is the Vice President of Sales for Mind's Eye. Terry, great to have you on. Tell us a little bit about Mind's Eye.
Sure. Thank you so much for having us. So Mind's Eye is an educational company. We focus on both aerial and ground vehicles in the drone market. We have a full-line education curriculum package that goes with those, and we're starting to branch off a little bit into some other areas and getting into our Mars rover with looking into the space technologies and that type thing, as well as getting into the ag market. And we have some our new autonomous tractors and agricultural items.
What exciting time it is for students in career technical education, whether it's ground drones, whether it's aerial drones, you're talking about Mars rovers, you're talking about precision agriculture, which is actually, as we're going to learn today, equally, if not even cooler than some of those other things. So tell us a little bit about some of the cutting-edge technology and the advancements that are taking place at Mind's Eye.
What we've learned is with ag and, well, with anything, technology changes as you go along. And with the agriculture, more and more so, we're really getting into fully autonomous farming. And the tractors are getting to where, honestly, they drive themselves a lot. We as humans are there to help with, if we come into an emergency situation or that type of thing, to hit the emergency stop button. And so, what we're trying to do is create a workforce out there of students that are knowledgeable and know how to do the programming of those tractors, and then know how to do some of the technical aspect of it, the reprogramming, maybe even some of the repairs and computer science parts of it, on the programming side.
And I think a lot of people may not even recognize yet, Terry, that a lot of agriculture now is being done autonomously. We're not completely there yet in some cases, but there's a lot of autonomous solutions that are out in the farm fields of America and around the globe right now, seeding, harvesting, fertilizing, the food that we eat, and the feed that we use for our livestock and so on. These are real jobs. These are real opportunities. Really exciting time to be in that space. Mind's Eye has taken the step to get into technology and hands-on learning systems that are going to bring those opportunities right into the classroom. So tell us a little bit more about the student experience as they're learning on the new products.
In doing our research and I've talked to ag instructors, I've talked to many colleges now teaching in the precision ag area and arena, and so truly it is where, like you said, not everything's fully autonomous, but we are getting into a lot of that. And so some of the things that they've already been doing is, for example, we're going to spray our field with fertilizer. So we need to understand how many gallons per acre we're going to spray and how much overspray we put on each row as we're going and those things. So those are things that get programmed into that particular sprayer so it knows how fast or how high to turn their pumps up as they go, that kind of thing. So as we're going into our curriculum, that's what we're trying to instill into the students and teach them as part of their math that's integrated into it, and some of the programming that they're doing. We use Arduino as a programming, so that's some of the programming that we're having the students do and figure out is, while we're on a much smaller scale teaching concept, so our students are going to have to figure out how many ounces per fleet that they spray versus gallons per acres, but those are some of the things that we're really getting into the students getting into.
So to be clear, we're not learning this on gigantic agriculture equipment, right? You've miniaturized this, you've put it into a size, brought it into the classroom. There's curriculum as well?
Yeah, so we have a full, really we can do a full semester curriculum on these. Primarily on our autonomous tractor, we have a 45-hour curriculum that's about a half semester. And then we have some of our implements as the students build and program those. You can easily extend that out into a full semester course.
And you talked a little bit about the competencies that students are learning, but go a little bit deeper. What is that experience like? What are they actually learning on the system?
So the main thing is they're in the computer science area of things, really doing the Arduino programming. They're going to do a lot of coding. They're going to start to understand the coding. And then from the engineering, there's the hands-on where they're actually building these kits. So when we start to build one of these kits, these students are building from the ground up. So they're doing everything from, putting the wheels on the tractor to they're building the transmission that goes into that tractor. So they're learning gear ratios and tolerances between those gears and how those work as well.
And we think about all the different career pathways that could apply to, certainly precision agriculture, but you start talking about things like gear ratios and mechanical drives and sensors and Arduinos and computer programming. It's really a wide range of different careers. Give us a sense for the type of careers you're preparing students.
Again, anything on the ag science, the ag side of things, but we can look at the automotive side. We're still the same gears and things go into your cars and trucks as they're going to go into a tractor. So same concepts there, but you're looking at the computer programming, so your computer science side, your IT side. So there's a lot of different career fields that it can be looking at.
And if I'm a teacher, I'm a STEM teacher, I'm an ag teacher, I'm an instructor at a technical college, tell me why I should put this technology in my classroom.
So I've got a lot of colleges and schools that we've been talking to as we develop this program. So they start talking about they have this $100,000 or $200,000 tractor, and they may have the ability to have some acreage that they plow on or whatever. Sure. So it's really about being able to teach the concepts and have it in a classroom size, a classroom setting, and safe, teach them the basic concepts and the programming before they allow them to go out and get on the really high-end expensive equipment.
Got it. And 30 students, one tractor, 30 students, maybe 15 or 10 or what have you. You get them around the technology, you're leveraging that investment, you're teaching them those technologies and those skills and competencies so they can then take it to the real thing with a renewed understanding and a much broader understanding of what it is that they'll be learning.
Yeah, and we do some intangible things too, like some of the social skills and team building and that kind of thing. So the way our curriculum is designed, we work with, we like to say 2 or 3 students per kit. So what that does is require your students to start to work together. You may have a stronger math student with a weaker one. You may have a stronger engineering building student, hands-on student, with someone who may be a little stronger on the computer side. So you start to teach them about those intangible things that we're, as an employer, you really look for, the people that have the good social skills and can work well with others and do the team building side.
And isn't that the magic of career technical education, where we're learning hands-on, we're learning with teams, we're learning how to interact with each other, we're learning valuable competencies that'll lead to incredible and amazing careers. I know the work that you're doing at Mind's Eye is inspiring hundreds and thousands of students around the United States and around the globe. So Terry Graham, Vice President of Sales for Mind's Eye, thank you so much for spending some time with us here on the Tech Ed Podcast.
Thank you. Thank you for having us. Appreciate it.
So many great conversations we had on this week's episode of the Tech Ed Podcast with people who are sincerely innovating in the world of technical education. Best of all, the beneficiaries of all these great innovations will be the students in the classrooms and labs across the United States of America and around the globe. If you have any products that you heard about today that you're interested in learning more about, please visit techedpodcast.com/ACTE. Thanks for joining us for this episode of the Tech Ed Podcast. If you haven't already, subscribe, leave a review, and if you liked this episode, share it with a friend. New episodes launch every Tuesday, so listen in next week.